In this video, I'm going to explain how to process Micasense Altum imagery on Drone2Map. These data were collected as 2D data because they were collected at nadir, which means they were pointing 90 degrees at the ground. And our sensor, which is a Micasense Altum sensor with multispectral and thermal capabilities, you can see all of the wavelengths that this drone measures on this table right here. And the sensor was mounted on a Matrice M200 by DJI. Our flight plan was done using Pix4D capture, and in total we have 1,992 images that we're going to process today. When you save your images with your drone or whatever format you're doing, you want to make sure that you are uploading images that are raw, that you haven't edited, changed any of the formatting on them, and you want to make sure they don't have any watermarks. More importantly, all of your images have to be saved as either a TIFF or a JPEG, and they need to include geolocation data. These can be automatically added to your images from your drone, or they may be added to a CSV file that you have to upload to Drone2Map. We also have GCP data, which we're going to add in Drone2Map so we can georeference our data. There's actually 5 GCP points. I forgot to mention that. And you want to make sure that you have your data for your GCP points saved as either a text or a GCP file. Okay. So we're going to then do our processing on Drone2Map. We're going to generate an orthomosaic, and there will be an orthomosaic for each one of the individual bands that we collect with the Micasense Altum. And then we'll also produce or generate a digital surface model as well as a digital terrain model. And these are pretty similar. The only difference is that the digital surface model is showing us the elevation of all the objects that are under our flight or that are being collected by our drone, whereas the digital terrain model is going to attempt to basically remove all of these objects and just show you the elevation of the barrier. I have mixed feelings about digital terrain models. I don't think they work as well as they could at this point in time, but they are a pretty cool output that you can generate with Drone2Map, and it might be helpful for your research. I'm going to teach you how to do that. And okay, so once you've generated your mosaic, your digital surface model, and your digital terrain model, you're done, and that's as far as the tutorial is going to go. But typically, somewhere between GCP data upload and data processing, we typically would conduct a radiometric calibration. And essentially, this is just taking a picture of a calibrated surface or a surface that reflects light evenly in every direction. You take an image of this panel before and after each drone flight, and then you upload these calibration panel images along with your drone imagery so that you can radiometrically calibrate your images and basically account for the differences in sun radiance in your imagery. So typically in other drone processing software like Pix4D, you're able to conduct this calibration in the software, but Drone2Map doesn't offer this feature at the moment, and they don't really have a way of integrating that calibration to Drone2Map. So you basically have to process these images on ArcGIS Pro if you want to radiometrically calibrate your Altum images. So the method for doing that is available through the ESRI website, and it's called creating an orthomapping surface or workspace for red edge or Altum imagery, and it shows you how to generate or start a new project. And basically here we go to the point where you have your reflectance panels, and then you're going to add your albedo values, which I've included here. These differ depending on your calibration panel, so you want to make sure they're correct for your panel by emailing ESRI, or pardon me, by emailing Micasense. And you're going to update these values to these right here, and then that's how you calibrate them. And then you basically have to generate a workspace on Drone2Map, on GIS Pro instead of Drone2Map. So just keep that in mind. If you need to radiometrically calibrate your images, this workflow is not for you. Okay, so we've talked about everything. So now we're going to start off by looking at our images and uploading them to Drone2Map. So the first thing you'll notice when you open your imagery is that you're going to have 6 images with the same capture number. So you see that this image number is 003, and then there's 003, 1, 2, 3, 4, 5, 6. These numbers are going to correspond to your band your band name. Okay, so your file suffix 1 is going to be your blue band, your file suffix 2 is going to be your green band, red edge, near infrared, and then the 6 is your thermal band. Something that's really important is you don't want to process your thermal and your multispectral images together. You actually want to separate them. So typically what I'll do is I will import all of my images to a new file because I don't want to work off of my raw data file. And then what will happen is then I'll generate or I'll create a file that has all of my multispectral images. So images 1 through 5, right? And then we also have a thermal file that has all of our images that have the suffix 6, which is our thermal wavelength, okay? Then I also create a different file for our pre-flight calibration panels and our post-flight calibration panels. Okay, so we have all of our images and they're separated and ready to be processed. And the last thing I always check before I start is our GCPs, right? Because we need to have ground control points for this processing that we're going to do today. And we need to make sure that our data is saved as a comma separated value file or a CSV file, which it is. And now we can start. So we're going to open up Drone2Map. And you'll notice there are several options for your project templates. The first is 2D Rapid. I would recommend using this if you're out in the field, if you're trying to make sure that all your images were collected properly and that they are georeferenced, very important. And today we're going to use the 2D full processing template. And the reason we're using this one is because it allows us to generate orthomosaics, digital elevation models, as well as multispectral reflectance maps. Last one that you have an option to process is the 3D mapping output, and we would be able to do this, or typically you do this with oblique images or images that were collected at an angle lower or smaller than 90 degrees. We did collect images at 90 degrees, so we're going to use this. We're going to give our project a name, and you want to select where in your computer you want to save it. That's up to you. And I would recommend with Altum Imagery, because we have so many images, to do the add folder selection. Okay, and then we have all of our images. We have our multispectral and our thermal. We're going to do our multispectral processing first because this one takes the longest. And basically, you just repeat this step for your thermal. So you go multispectral. And you will notice this will take a minute because we have a lot of images. Okay, so once we've uploaded all of our images, the first thing that I do is I make sure that we have a green check mark on the left-hand side of all of our images. We also have our GPS data associated with all of our images. We have our latitude, our longitude, and our altitude, and then some basic information. Click create now. So you'll notice the first thing you'll see is that your imagery will be shown. All of your individual images are going to be shown on your map, as you can see here. This is your flight plan, and if you click on each image, you will notice that there's again the repeat image 5 times, and then we go back. So 5 times with the same image, and then it keeps going. That looks correct. So again, I always make sure that I look at my first image, my last image, because all your images have to be taken from the full flight altitude. Sometimes the drone will malfunction a little bit and we'll take images at takeoff and landing. And you want to make sure that you remove all those images because they are going to mess up your processing. Also, any images that might have been collected when it was flying back to its processing location may not be the best images to include. So you might want to delete those as well and just keep your nice clean flight plan. If you want to delete an image, just click on it and you can press delete on your keyboard or just click on flight data, just remove images, and that should get rid of it. Okay. So Because it is a multispectral sensor, I always define my cameras. And what that means is that I tell Drone2Map what the name of each camera is so that it'll generate 5 separate orthomosaics. This is not always necessary. I have processed my Altum imagery before without defining my cameras, but I have noticed that things work a lot better if I do this. So the way that you do this is you're going to open your image table, and you will notice that you'll have all your individual images. I'm going to sort them by image name. Okay. And you'll notice that there's no group name. So what I'm going to do is I'm going to add all of the images that are from the same band to the same group, and that way the Drone2Map will know that all those images are together. Okay, so the way you do this is you go into select by attributes, and you're going to start a new expression. And all of the images have the same file suffix. So this last bit of the file, so we're going to do where the image ends with, and then we can put down the first band, which is 1, and this is going to vary depending on which drone you're using or which sensor, but for the Altum, Red Edge, and thermal sensor, these are our band names. This is going to vary depending on which sensor you have. Again, very important, don't forget that. And so the first one is called blue, so we're going to say select, and it's going to select all of our images that are from the blue wavelength, and then you're going to say group name up here, and you're going to name them blue. You can also name them the wavelength, so 475 if that's better for your application, or you can just name them B, whatever you want. Just give them a name that you know what it means. Click OK, and you will notice that all of your 1 wavelengths are now populated as blue. Okay. The next step is just to hit clear to make sure you remove that selection, and then you just go on to your next wavelength, which is number 2. Click select, and then again, group name, that's number 3, or the green wavelength. So we're just going to click OK, clear. So this was really important because you might think that because of the order of the wavelengths, the band 4 would be red edge, but it's actually near infrared. So make sure that you are paying attention to your band names and your suffix, because number 4 is near infrared, not red edge, even though it's the next one in line based on the wavelength. Okay. Okay, so we don't have the 6 wavelengths because again, we're going to process them separately. So we're not going to have our thermal data in our processing. Okay, so we do clear, and then we just want to make sure that all of our images have a group name. We want to make sure that all of our groups are present, that we didn't overwrite one of them by mistake. So we have near infrared, red edge, blue, green, red. So we have all of them. And I just do a quick check, make sure that everybody has something. And it looks like they do. So now we can just hit save and go on to our next step. And now the next step is to add our ground control points. So you can add ground control points in several ways. You can add them as a CSV or text file, which is what we'll do in this tutorial. But you can also do a Drone2Map control export. You can import a feature class, or you can import hosted feature layers. If you're interested in these, there's a lot of information on the Drone2Map help website. So when you import controls, You want to make sure that you import them from a CSV or a text file. Again, this is a CSV file. Okay, you want to make sure their coordinate system is whatever your GPS uses. You can add control photos if that's helpful for your research or your work. And then you just want to tell Drone2Map where your data is saved. So your latitude, your longitude, and your elevation data. You might have accuracy data available to you. And then last, you want to have your control photo name. And this is whatever number is on your reference panel, whatever name you gave that site, whatever that may be. This is important if your data, especially for some of the near infrared and red edge wavelengths, it can be a little bit hard to orient yourself in the space sometimes. So it's nice to be able to look at the numbers and be able to look back at them. So just click OK. And Drone2Map should automatically populate your ground control points on your map. If you upload your ground control points and you don't see them, just right click on them and then do zoom to layer, and it'll show you where they are. If they look like they're halfway around the world, it means you have the wrong georeferencing. So go back and fix your georeferencing, okay? So once we have our GCPs, now we can mark them on our images. So we can see all of them right here on this lovely box. And then you're going to click Show Image Link Editor right here. And then you'll be able to see all of your individual images. Here they are. And then you can see your different ground control points. You can see that we are using ground control points, not checkpoints. You can use checkpoints if you have, let's say, half that you want to use as ground control points, and then a certain number that you want to use to see how accurate your georeferencing was, then you would use checkpoints as well, but we're just going to do ground control points. And the way that I do this, it's kind of challenging to do this because there's no way to standardize how zoomed in you are as far as I know. But what I try to do is I try to zoom right to the edge of my ground control points, right? So the edges of my GCP are touching the edge of my window. And that way I know that I'm zoomed in more or less the same amount every time I mark my GCP, okay? We want to make sure all of our GCPs are marked with the same accuracy. And we want to make sure that we're being as consistent as possible. So we want to make sure we get as close to the middle as we can, and that we're equally meticulous about this every step. So if you're doing this, just make sure you're consistent. And we're only going to add 5 image links to each image. So each one of these little crosses is called an image link. And you can see how many image links you have on your map right here. The link 5, you have a little green check mark once you have at least 2 images marked, which is the minimum. But in general, the rule of thumb is you want to have between 3 to 8 image links for the best result. Okay, so we're going to do 5 of the first ones, right? And then because there's 5 of each image, this means that essentially we just did 1 image, okay? Because they're all taking a picture of the exact same thing. You look at them, zoom out all the way. You look at them, they're all the exact same image. So I want to make sure that I have some image links and images that are facing the other direction, for example, or at least that are different. So what I usually do is I do 10, and then for the first 5, I always do the same image, so it has the same image for each band, and then I kind of go through and I do all 5 again from random ones. So I'll go 2, see this one's upside down, I like that. That gives it a little bit more information to play with. So a 2, I'm going to do a 4 next. A 3. A 1. And then a 5. Yep. So there we go. So now we have 10 total. So we have 5 from the first 5, and then we have 5 of each of the other wavelengths, but at random. Typically, and this is something that's really weird that happens sometimes on Drone2Map, typically you would be able to, once you have enough, you should be able to click this this button right here that says auto link, which means that after you have a certain number of images, it'll automatically add these tie points or these links to all of the images that are in common. And for some reason, this button isn't working today. I teach a Drone2Map class, and I've had some students where this button is disabled for some reason. I'm not exactly sure why that is, but for some reason, sometimes it doesn't allow you to do that. But if that button is enabled to you, just click auto links, and then when you want to make sure that those links are correct and kind of move this little square around depending on how it looks. Okay, because it's not super perfect. You want to double check and clean that up. Okay, so now I'm just going to do this for all of my GCPs. Okay, so I've done some editing magic, and now I've marked all of my GCP points. And I have 12 links for all of my imagery. And you'll notice that once you have enough links, you'll get this green check mark on the left-hand side of your GCP table. So we're done with that. Just click OK. And then all that's left to do is usually to manage or change your options for processing. So we always want to run an initial run. We're going to do a full processing because we want to have as high of a resolution as possible. And we're going to use the aerial grid or corridor for a matching pair method. And if you were to have done a free slide or a terrestrial monitoring, you'll use this one. And if you want to change your matching pair settings for any reason, then you can use this one. Typically, the automatic works pretty well. And down here, you just have options for sharing or for modifying your matching strategy, your target number of key points, your camera optimizations, as well as rematching. And then we're going to generate some 2D products today. So the first one's going to be an orthomosaic, which is basically like a puzzle of all of your images that are stitched together to create one cohesive image. You can change the resolution of your orthomosaic here. I'm going to do the full resolution, which is the automatic, but you can also increase it to have a coarser resolution. And you can also do a user-defined if you're trying to downsample to match the resolution of a flight that was conducted at a different altitude with the same sensor. Or if you're trying to, for example, compare images to satellite imagery or imagery from a different drone sensor. And then we're also going to generate a digital surface model. I typically use the inverse distance method. And then we're also going to generate a digital terrain model. And typically this one will have a much higher ground sampling distance as your orthomosaic. And this is because if you're trying to do terrain, the change in terrain level isn't going to be at a centimeter level. So it's really typically not necessary to have it at the full resolution. If you do the digital terrain model at a lower resolution, it might take a little bit longer because that's more processing. You can also generate 2D products, which we won't do for this exercise. And typically when you process 3D imagery, you want to collect it at an oblique angle rather than at 90 degrees, which is what we did. Okay, so now that we're done, all we have to do is click start. And then you'll see it'll save the project and then it'll start processing. This is my imagery after it has finished processing. You can see that it's generated an orthomosaic as well as a digital surface model and a digital terrain model. Sometimes when your image is processed or your output, it'll have the bands are going to be mixed up. So if you notice that the red is labeled as blue and the green is labeled as red, etc., all you have to do is click on it with your right click and then just click the appropriate band for RGB and then it'll display properly. Okay. You'll notice that my RGB doesn't look very nice, and that's because this is over water and the drone does not have an easy time stitching imagery together that was collected over water. Even these floating docks right here, these move around a lot based on the current. So you'll notice that there's a little bit of blurriness, and that's because these are swinging back and forth, and as the drone goes over them, they're not going to match perfectly one to the other. Okay, so that's pretty normal for aquatic drone data. We also have our digital surface model, and honestly, this isn't going to be very exciting because I don't have a lot of structures, but you are able to see the docks, you're able to see the edge of the ponds. I would not trust any of the elevation measurements over water, to be completely honest with you, again, because the drone has a hard time stitching these images together. But you can see where there's a little bit of a ditch on this side of the pond, and you can see the aerator engines right here. Now for a digital train model, it's supposed to remove all structures, and it did do a good job of removing our aerators, but for the most part, this isn't a very good example of the use of a digital train model, but I wanted to show you what that output looks like. Now, some of the things you can do with these imagery is you can do some measurements. You can measure distance. If you want to see how big these docks are, for example, you can just do a quick measurement, and then you'll be able to see your different distances and all your information over here. You can also open your images or your data in ArcGIS Pro if you want to do any advanced analyses. Also, if you want to calculate any vegetation indices, you are able to process some vegetation indices directly on Drone2Map. So for example, you can process the normalized difference vegetation index, which is NDVI. So you just have to tell it which one has the near infrared band and which one has the red band. Click OK, and it'll automatically generate your NDVI. So there's our NDVI output. Makes sense, right? This is grass over here. The water is shown as red because even though there is some photosynthetic activity happening in there because of the algae, it's still going to be a lot lower than the grass. And if you don't like this color scheme, I like more of a ramp color scheme for my NDVI. You can just right click your layer, go to symbology, and then you can do stretch, which is what I like to use. And I like to show it more clearly with something like this. And I also like to keep it from -1 to 1 because that's the range of NDVI, and you have to invert it. There we go. So there we go. So now we see our green, our grass is green. It has the highest NDVI values. And then the dirt has low NDVI values, and so does the water. Okay, so you can do a few different vegetation indices on here, but if you want to calculate additional indices, you have to open your imagery in GIS Pro and do a band ratio or a raster calculator function. Okay, you can also draw elevation and spectral profiles, which can be pretty cool. For example, for a spectral profile, you click right here. And then you can do, for example, a point. And then it'll give you the spectral information for that particular area. Okay, so that's pretty cool. You can also export your data as a raster. You can do some digital sharing options, and you can also do some additional things such as resampling. You can do stretches. There's a few different options, but for the most part, this is what your output's going to be from Drone2Map. And yeah, so this is your output for your multispectral imagery. When you process your thermal imagery, it's going to be very similar. The only difference is instead of having 6 of the same image, you're going to only have 1. It's going to be a little bit harder to process your TCPs, but essentially the entire method just repeats, only instead of 6, you only have 1. You don't have to define your cameras. Something else that you might want to be aware of is the processing report, really important. So it tells you some important information about how many key points were generated per image, how many of them were calibrated, whether there was difference between the optimized and internal camera parameters, the median number of matches per image, as well as the ground control points and whether they are correct georeferencing for them. You can see where the drone has some images generating high points, and for the most part, that's going to be over the water because, again, it's really hard for the drone to find commonalities between the imagery over water, and you can see that really clearly right here. So this is part where it's basically just the open water and it had a really hard time finding matching pairs. And then there's just a lot of really good information that you might be interested in. This is a great place to kind of figure out how accurate your data is and if there's anything that you need to be tweaking to get a better result. You can also access your report right here. If you want to have your PDF in order to share it with a colleague or something, or to turn in for your class, you can just access your processing report PDF right here, and there it is.